This video takes you through my journey using a platform designed to teach myself for embedded programming, covering essential topics like real-time operating systems, graphics, networking, and user input handling. Through hands-on learning, I develop practical skills and gain a deeper understanding of how embedded systems work in real-world applications. In 2004, I've bought a display from a friend who was looking to sell it, hooked it up to my PC's parallel port, and I started experimenting with it. Later, I integrated the display into a mini tool case by removing the tools and securely fixing the display inside. To enhance this functionality, I added buttons, salvaged from our old keyboard, each extended with two LEDs for improved interactivity and visual feedback. Years before Arduino and Raspberry Pi became popular, I was searching for affordable solutions for embedded computing. That's when I came across the WebCat embedded system, a budget-friendly evaluation board with an Ethernet interface which I purchased for €100 on eBay. The board is equipped with an ATmega128 RISC microcontroller, an Ethernet controller, 32 kilobytes of external SRAM, 32 kilobytes of EEPROM, an LCD interface, a pin header for the remaining microcontroller IOs, a reset controller, and an onboard voltage regulator. The most remarkable feature of this board was its full compatibility with NTOS, a real-time operating system developed by Ignite. This allowed for multithreaded applications, including Ethernet support, making it a powerful and flexible platform for embedded development. The standout features of this real-time operating systems for me were priority-based cooperative multithreading, a built-in TCP/IP stack for seamless intranet and internet connectivity, a DHCP client, an HTTP library for retrieving data from the web, like weather information, network time protocol for time synchronization, DNS client, and back then a feature-rich, script-driven graphical user interface tool that made configuration incredibly easy. NTOS was developed by the open source community and published under the BSD license. Over the course of 9 years, I expanded this platform by adding various graphical elements: a DCF77 receiver, a wireless transmitter for home automation, and even a true random number generator circuit that shared a high-quality random number service across my local network. However, I primarily used this device as an alarm clock with NTP and DCF77 functionality. I have created and may continue to make videos covering specialized topics related to the system. Let me know in the comments what you would like to see next. And don't forget to like and subscribe to stay updated on future content. 20 years later, I've come to a realization, while I haven't built anything remarkable for sure, I have learned an incredible amount about embedded computing. It was undoubtedly time well spent.